Okay, so we're going to work on the differential. And we have talked about how we see this, how we are familiar with this dx being roughly equivalent to the change of x. And we know this from the dy by dx, which is change of y over change of x. So we did that with derivatives. But another way that we can use this is we can be given a formula that is a derivative, dy by dx. Say dy by dx is 8x to the third plus 3x to the second minus 3. And what I'm told here is this is the derivative for some function. Well, what if I want to know what the function is? What if I want to know what y is? Well, I can say, well, dy is the same as 8x to the third plus 3x to the second minus 3 by dx. And then because both sides have a differential now, I can find an integral. And the integral of just dy would be y, because the derivative of y is just dy. And then I can say that this is going to be 8x to the 4 over 4 plus 3x to the third over 3 minus 3x plus c. So y would have to be 2x to the fourth plus x to the third minus 3x plus c. Now, this is as far as I can go. I was given the derivative. I'm asked to find y, and this is as close as I can get without the given information. But in many cases, we are told the initial condition, or a condition, where y of 1 is equal to 1. Well, now I have some information that I can plug into this equation to figure out what that c is. So I come back and I go, okay, well 1, since y is 1, is 2 times 1 to the fourth plus 1 to the third minus 3 times 1 plus c. And 1 equals 2 plus 1 minus 3 plus c. And two plus 1 equals 2 plus 1 is 3 minus 3 plus c. That's 0, so c is equal to 1. So that means y is equal to 2x to the fourth plus x to the third minus 3x plus 1. And now, from the information of the differential and that value, I was able to figure out the full function for y. That's another way we can use our new knowledge. So we'll try another one. Number 2, dy by dz is equal to sine of 2z. And I know that y of pi over 4 equals 4. Find y. So if dy by dz equals sine of 2z, I can move this differential over. Now I'm ready to integrate. So the integral of dy is just y, because the derivative of y is 1 dy. 1/2 negative cosine 2z plus c. And that's because if I find the derivative of this, I'm going to end up right back at 2 sine 2z. So now I have this added information. 4 equals negative 1/2 cosine of 2 times pi over 4 plus c. That's 2. Cosine of pi over 2 is 0, so c is equal to 4. So y is equal to negative 1/2 cosine of 2z plus 4. So I have one for you to try on your own, or if you haven't tried it already. 3. dy by dx is equal to e to the negative x. And y of 1 equals 1. Find y. Pause it now if you would like to try your own. dy equals e to the negative x dx. Find the integral. Y is equal to negative e to the negative x plus c. 1 equals negative e to the negative 1 plus c. 1 is equal to negative 1 over e plus c. C is equal to 1 plus 1 over e. So y is equal to negative e to the negative x plus 1 over e. What if I gave you more than one initial condition and more than one derivative? Y prime, double prime, is equal to x to the third minus 2x plus 1. Y prime of 0 is equal to 1. Y of 0 is equal to 0. Find y. Well, since I'm starting at the second derivative, I actually have to do this twice, which is why I need both initial conditions. So dy d squared y over dx squared is equal to x to the third minus 2x plus 1. And in this case, I'm going to go at when I find the integral. When I find the integral to both sides, I am actually only going to be at the first derivative. So y prime equals x to the fourth over 4 minus 2x to the second over 2 plus x plus c. So I have to use this guy. 1 equals 0 over 4 over 4. Those divide out, minus 0 squared plus 0 plus c. C is equal to 1. So now I know dy by dx is equal to x to the 4 over 4 minus x to the second plus x plus 1. So the integral of dy equals x to the 4 over 4 minus x to the second plus x plus 1 dx. Oh, find that integral. And I'm going to be at y equals x to the 5 over 5 minus x to the third over 3 plus x to the second over 2 plus x plus c. And I know that the 0, 0. So 0 equals 0 minus 0 plus 0 plus 0 plus c. C is going to be 0. So that means my final iteration is y is going to be x to the 5 over 5 minus x to the 3 over 3 plus x to the second over 2 plus x. And there is no plus c because we've taken care of that initial situation.